This is Django Riffs, a podcast for learning web application development in Python using the Django web framework. We explore all of Django's features to equip you with the knowledge to build your own web app. I'm your host, Matt Lehman. Episode 6, Where Does the Data Go? Welcome back to Django Riffs. On this episode, we're going to be talking about data. The data that you need to store in your application, the data you want to fetch from your application. Django gives you tools for putting it somewhere, and we need to figure out where that goes. We need to understand what's available to you and how Django chooses to expose that to users and developers like yourself. On the last episode, we talked about forms and how to interact with users using forms to collect data. And that was great to give you an introduction to interaction on the web and using HTML forms. And this time, we're going to take a look at the data to find out, now that you've collected data from a user, where can I store it? We'll need to get into setting up your system to actually collect data. And the big thing to understand about data collection in Django is that Django is designed really to use relational databases. Relational databases are the technology that we're going to talk about heavily in this whole process. And I'm going to walk you through a little bit about database stuff and understanding databases. From there, we'll talk about how Django uses that technology to give you a place to store your stuff. So let's dig into it. What is a relational database? If you've never worked with databases before, I think the best analogy that I could come up with is to think of a database as kind of like a collection of spreadsheets. And the spreadsheets in a database, they're given a different name. We call them tables. And a table is like any tabular kind of data that you might experience in a word processor or any variety of circumstances. It has columns and it has rows. And usually the columns are the kind of data that you would want to track about some individual information. And then the rows of a table are the individual pieces of information that you care about. For instance, if we had an employee table, like say you're at a company and you need to track information about the employees that work at the company, you might have a table to do that. And if you were working with some kind of internal database. And perhaps that table looks like this. Maybe it has a first name and a last name and a job title. It's a simple table, and I understand that first name and last name are not always representative of the world. So we're just going to work with that as just sort of notional, but it kind of gives you an idea of what might go into a table, and it makes for a clear discussion point. The table in the database is what can store all that information. Each row in it is going to map to an individual employee that might exist at that company and track that information about them, what their name is, what their job title is. We haven't really talked about the relational part of it, though. The relational part of a relational database comes into play when you want different tables to compare with each other. So let's think about, for example, phone numbers. If an employee is working at a company, they probably have some kind of access to a telephone. And the question is, how would you store that in a database? In a very simplified model, you might add a phone number column to the same employee database table. So if all you ever cared about was a single phone number for an employee, that would be perfectly adequate to store that information. But that doesn't really model the real world well. An employee could have multiple kinds of phone numbers. Perhaps they need to be contacted at home, or have a work number, or have a cell phone number, or some employees might have fax numbers or pager numbers, depending on the kind of work that you do. There's all different kinds of phone numbers that exist in the world. If that's the case, how could you model that in a table? You could take a pretty extreme version of this and put in multiple phone number columns in the same employee table, and then kind of have this opportunity or slots for different phone numbers to go in there. But that's going to be pretty wasteful because many employees may only have a single phone number that they want to be contacted in. So how do you account for that one employee who has, 8 phone numbers versus the average employee who has 1 or 2? It's not going to be a very workable system. So the relational part of a relational database gives the opportunity to create multiple tables in your database and link them together in a way. We'll talk more about linkage of the tables in the future, but I just wanted to give you an idea right now of what a relational database is. Relational database gives you the tools to say this one employee can have many phone numbers in a different table, and there are tools that wire that together. So Django uses relational databases as the underlying technology of how it does data storage. Tables are a wildly powerful tool to model most circumstances that you might find with the average application. And because of that, Django has very tight integration with relational databases. If you were to start a new project in Django and you use the start project command, you can open up your settings.py file, and you can find in there, you can find a setting called databases. Let's talk through this little block of configuration a little bit to give you an idea of the pieces that are in play so that you can have a better understanding of how Django starts to connect to a database. Like we saw in our templates study earlier, there are multiple databases that can be used, just like there were multiple template engines that could be used. And the Django settings for databases give you the ability to specify which kind of database you want to use. So if you run the standard start project command, you're going to see something that looks like this. The database's configuration setting will be a dictionary. And in that dictionary will be a key of default, which will then have another dictionary as the value. And that dictionary has two keys. One is named engine, and the other is name. And the engine points to a value of Django.db.backends.SQLite3. And the name is an operating system path. It's an os.path.join on the base directory of your project, coupled with a value of db.SQLite. So if we break this down, what we're saying is what we want to do is use a database technology called SQLite, and we want the name of that database to be db.SQLite3. So the powerful part about this settings configuration is that this is just one type of database engine. The engine for the database is the code that Django works with whenever it wants to talk to a database. So it's kind of the translation layer that happens at the lower level between Django business logic, or just Django logic if you want to view it that way, and an actual database operation to get data in and out of a database. There are a variety of database engines that exist that are supported officially by the Django project. That includes SQLite, as you can see from the start project command. It will also include Postgres and MySQL. I believe it supports Oracle as well, but you can check the documentation to see all the officially supported databases, and you might be able to find some community-supported ones for things that Django doesn't support directly itself. Why does the start project command give us this SQLite database by default? The reason has to do with the fact that SQLite is a single file database. It's also something that is essentially universally installed. SQLite is built into just about every installation of Python you could imagine. It is something that is very accessible to the average people. If you've never encountered it before, it is technology that is in virtually every mobile phone on the planet. It is probably the most ubiquitous database out there. And because it's so available, it also really lowers the barrier for any new person who wants to come in and start using Django. As I said, SQLite is a single file. And so when you create a database using this particular engine, Django will put that file right on your operating system, and you don't have to learn all about extra database configuration. So that's really powerful. It's a good way to get into Django, to learn how it works, to get exposure to it. And SQLite is so capable that you can get virtually all the functionality that you would out of other databases without any configuration. That's pretty awesome. if SQLite is so awesome, then why do we even have other engines? What's the point? Why would we offer this as a configuration? Well, the reality is that SQLite, while great, is not best suited for all scenarios. It's an amazing little tool, but it has some big limitations. And one of those big limitations is that multiple users cannot write and update it at the same time. You can imagine a database that serves perhaps 10,000, 100,000 users all at the same time, all wanting to write to a database. If you can only have one writer at a time, you're going to have a big problem. There's going to be a lot of contention for that resource. So because of that, Django supports other databases. So if you're going to pick another database for your application, which I think you're very likely to if you're putting something on the web, I would recommend Postgresql. Postgresql is an open source database. It's wildly supported as well, and its open source nature makes it very approachable. There's a lot of good documentation out of there, and Django does a great job supporting that particular SQL database. We can talk more about database configuration in the future. We maybe will get into that a little bit more if we cover the subject of deployment in a different podcast episode. But for now, going forward with these examples, you don't have to change anything. You can learn Django and learn with SQLite, and you'd be well set for anything that we're going to be going over. That's a little bit about the configuration of databases within the settings. It gives you a brief understanding of how Django works with different types of databases. And now we're ready to move on. We're ready to move on to how Django works with databases at the code level. When you're working with a Django database, you're not really working directly with a table. Instead, Django gives you this different kind of concept to work with entirely. And that concept is called a model. A model is a Python class. A Python class is frankly similar to a Django form in a lot of ways. It's something that you declare, you subclass from, in this case, a model superclass rather than a form superclass. And you're going to add, just as with the form, declarative types of data that you want to be in your model. So this is where you add all of the extra information that represents the things that you want to put in the table. Any entry that goes into your model will represent a column in a database table. If you look closely at the model field types that are available, you'll see there's a lot of overlap with the form field types. And this is for good reason, because the data that you want to collect from users in a form will often match pretty well with what you want to ultimately store in a database. Let's look at an example to make this clear. Earlier we talked about an employee table, and that employee table had just a few attributes. So that's what we're going to use as our working example for this discussion. In our example, we're going to use a models.py file. So in a Django application, again, which I will just refer to as application, in a models.py file in that directory, we're going to do this. From django.db, import models. And then we're going to declare a class. That class we're going to name employee, as in the singular, one employee. And it will subclass from models.model. And there are going to be 3 class level attributes on this particular model in order to match up with our table description from above. We'll have a first name attribute, which will be models.car field. That's C-H-A-R field. And car in that case, I don't know actually why I call it car. Maybe it's a historical thing, but its character is where it's coming from. So, but take that for what it will. I've always heard it called car field. Anyway, there's also a last name field, which will also be a character field, and a job title. And we're going to use a character field again. And the reason I'm using a single data type is because I want this particular example to, as we start, to be really clear without getting into other data types. The point is to understand what a model is and not get bogged down in different field types. So as we look at this model, we see that it describes the pieces of data that we want to include in the table. Each model class represents a single table in a database. A database can contain any number of tables. I'm sure that's limited to memory and other sort of constraints, but for all practical purposes, you can have as many tables as you can possibly work with. I mentioned earlier that we might have phone numbers that we want to track. So if we wanted a separate table, then we would create a separate class. So we might create a class called phone number to store phone numbers and types of phone numbers that you might have. Conventionally, we use a singular name for the class rather than the plural because we're going to instantiate these like objects. And the instantiated version of a class instance is going to represent a row in the database. Let's look at an example of that. So if we've got a Python REPL, we can do from application.models import employee. And from there, we can create an employee instance. And that employee can take a bunch of keyword arguments that map exactly to the fields that we added in our class declaration. So we can say first name is a value of Tom, and last name is Bombadil, and job title is Old Forest Keeper. I'm a big Lord of the Rings nerd, so deal with my crazy examples. And so from here, we now have an employee record that we could start to work with. But there's a problem with this so far, and that problem is that if you try and actually save this record to the database with the amount of setup that we've done to this point, it's going to fail. And it's going to fail because although we have declared what table we ultimately want in the database, we have not told the database to update itself to be in that state. In other words, Django has some idea of what it wants the structure to be in the database, but Django has not issued any kinds of commands in order to make the database be in the right structure and have the tables that will keep the two in sync with each other. In order to get those things together, we have to look at one extra set of tools that Django provides to make sure that your data in your models matches up with your data in your databases. And that extra piece is called the Django migration system. So that's what we'll look at next. We know that Django models are Python classes that map to database tables. But those database tables don't magically appear. We need some ability to set them up, and there's something that we have to run in order to get Django to set them up properly. And that is this migration system. So what is a Django migration? Well, it's a bunch of things, but in the end, it sort of boils down to a set of files, a set of Python files that live with your project, that describe the sequence of operations that need to be applied to a database to make the definition that exists in your Python files match up with what a database expects, so that when Django wants to send commands to the database to add or remove data, it will do that, and the two will be in sync with each other on what data even exists and what options are even available. These migration files that you will find in a Python project that has database migrations, which will be basically all of them, are abstract operations. So if you look at them, they aren't actual SQL code, SQL kind of code that goes into relational databases. What they are instead is Python translations of what you might add to a database. For instance, if you're adding a new field to a model in a table, a Django migration will have some representation of adding a field. And what will happen is the engine that, for whatever database you're working in, will take that abstract operation that exists in the migration file and translate that into the kind of command that the database itself needs to know in order to update itself properly. The nice part about having abstract operations in these migration files is that when it comes time to switch databases, if you ever needed to, for example, like if you're starting a project using SQLite and then you want to put it up on the internet and switch to Postgres, then you can do that. The migrations have kind of captured the state of the system, and the engine will do the proper translation so that when you apply the migrations to the target database that you want for your application, they will sync up, regardless of whether SQLite or Postgres is used. And this is important because SQL databases speak slight variants with each other. They all ultimately speak what's referred to as structured query language. That's what SQL stands for. And that is the language that is used to actually communicate to a database. It's the commands that are used. And most of the databases that we look at have a very similar structure and pattern, but like any natural language, there are dialect variances. I speak American English, and the words that I say in English are going to be different from someone in Great Britain, someone in Australia, because of just differences in culture that have happened over the years, and something similar happens at the SQL level. The developers for Postgres, the developers for SQLite, MySQL, you pick your database technology, they all try to adhere to the standards, but there are going to be slight differences because of the way those technologies were built. And the engine's job is to smooth over those differences so that what you get at the Django level is all the same. Common abstraction. And when the differences exist, the engine has covered over that, and you don't even need to know about it, which is really nice. To use the migration system, there are a couple of commands that you need to learn. In reality, there's actually a few, but the most important ones are the two that I'm about to mention. The first is the make migrations command. Earlier, when we created our employee table, the database has no knowledge of that employee table yet. I'm anthropomorphizing the database, but bear with me. The database doesn't know about the employee table because we haven't synchronized that across. So you have to create a migration file that will be the instructions that Django can use to actually do the update on the database. So if we have an example where we run .manage.py, make migrations as the command, we'll get some output, and a migrations file will be added to a migrations directory for your application. And if you're just starting out, the name of the first migration is always 0001 underscore initial.py. There's nothing magical about that name. That's just what the migration system will do. You can rename these files, and that's okay, but that is what Django will call the first one by default. We need a migration anytime we make changes to models. If you're adding a new field, if you're modifying existing fields, if you're deleting existing fields, or even if you're changing some metadata about fields in certain cases, all of those that affect the database will require some kind of database migration in order to keep the model in sync with the database tables. If you don't make a migration, you're going to encounter errors, most likely. And the reason for that is because Django will try to put together SQL commands, that will query for information or ask for information that may not exist. So if you ask for a column in a database table that doesn't exist, a database is going to say, I don't know what you're talking about because I don't know what this column is. And Django operates under the assumption that the database tables will match up with the Python code. So making the migrations is one step of the equation, and that's to put together everything that needs to go into the changes that describe the operations to keep things in sync, but then we have to actually apply them. And that's where the migrate command comes in. So the migrate command is like any other Django command. You can run it with .manage.py migrate, and if there are things to apply to a database, it will try to apply them. In fact, if you are starting from start project and you've got a basic Django project structure put together that has not modified any installed applications and run manage.py migrate, you're going to see quite a bit of output. And the reason for that is that Django itself uses in its own internal applications the migration system. So the default start project comes with a variety of Django apps. This is what's useful for providing the Django admin interface that we haven't covered yet, and a bunch of other things. So the first migration is going to include migrations from content types and auth and admin and sessions and applications like that, things that you'll find in the installed apps list. And the reason that these migrations exist is that these models that are core to Django have evolved over time and have changes. And so we need to apply all of the migrations to make sure that the default models that come with a Django app that you may not see in your own application, but are internal to the Django app code, are applied, and so that the Django model state in the Python code will match up with the database tables. When you run the migration, you should also see your own app migration applied. So if we've created our employee model and we've got our initial migration generated from our make migrations command, then we'll also see application migration in that list as well. So that will let us know that our employee table has been created in the process. There are some other migration commands that are useful. There's one to show migrations. There's one to get out the SQL operations that are going to happen with migration. All of those things are useful to know, but the core that you need to know about is the way to create new migrations for your database tables and the way to apply those migrations to the tables. And that is the fundamentals of migrations. At this point, we've covered the core of what Django does to store data for your application. We use relational databases. Relational databases are sets of tables. Those tables store columns that represent each type of data that you want, and rows, which are the individual instances, like our employee example where you might have multiple employees and one per row. We've talked about models and how models are the Python class that we're going to use to interact with that data. And Django is going to do all the work to actually store data in a database, but the thing that we get to work with is this nice abstract model concept that lets us work in the domain of our problem rather than dealing with the fiddly bits of dealing with a table. And then finally, we saw how Django will synchronize models to a database with the migration system. In the next episode, we're going to go much deeper into models. I wanted this episode to be an exploration of the basics and understanding the setup and understanding what the technology is that is the core of everything here. And then we'll start talking about how to actually work with models to see them in action. Full show notes for this episode are available at www.mattlehman.com/DjangoRiffs/6. Thanks for listening to this episode of Django Riffs. You can follow the show at djangoriffs.com. If you have something to share, feel free to reach out to me on Twitter. My Twitter handle is mblayman, or follow the Django Riffs handle to keep up with the show. If you've enjoyed the show, please rate or review on iTunes, Spotify, or from wherever you listen to podcasts. Your rating will help others discover the podcast, and I would be very grateful. Django Riffs is supported by listeners like you. If you can contribute financially to cover hosting and production costs, please check out my Patreon page at www.patreon.com/mblayman. The theme music for Django Riffs is Open Roads, used with permission from Purple Planet Music. I hope you'll join us next time to learn more about Django. Take care.